You've seen them on your cereal box, on your new headphones, even on the book you just bought. Yep, those little black and white lines are literally everywhere. They're a silent, universal code on pretty much everything we buy.
But have you ever been at the checkout, heard that super familiar beep, and just wondered? Like, what information is actually packed into that simple pattern? It's one of the most common symbols in our world, but honestly, it's also one of the most misunderstood.
So, at its very core, that's all a barcode is. It's a visual language, but it's not designed for our eyes, it's made for machines. Think of it as a way to translate product data into a pattern that a computer can read in, like a split second. Now here's the #1 thing people get wrong. A barcode doesn't actually store all the product's info within its lines. It's much simpler than that. The best way to think about it is like a license plate. A license plate is just a unique number, right? It's a reference key. A scanner, or the DMV, looks up that number in a database to get all the details about the car. Well, that's exactly what's happening with your groceries. Okay, so how does that lookup actually happen? How does a simple beam of red light turn those lines into useful info? The process is actually pretty genius in its simplicity. It all happens in 3 super fast steps. First, the scanner shines a light onto the code. The white spaces reflect a ton of light back, while the black bars absorb it. The scanner's sensor reads this on-off pattern of reflected light and decodes it back into the original numbers. Then, that number gets zapped over to the store's computer, which instantly finds the product in its database and pulls up the price, how many are in stock, the whole shebang.
But you've probably noticed that not all barcodes look the same. And that's because there's a whole family of them, and each one is designed for a different job, from tracking a package across the world to just ringing up a can of beans.
They're basically split into 2 main camps. On one side, you have the classic 1D, or linear barcodes. That's your standard UPC code on stuff you buy. They hold just a little bit of data, and you have to scan them in a straight line. But on the other side are the 2D, or matrix barcodes. Think QR codes, which are everywhere now. These guys can hold way more information, like an entire website address, and you can scan them from any angle with your phone. Pretty cool.
And even within that 1D family, you've got a few key players. The UPC is without a doubt the king of retail. But you've also got code 39, which is alphanumeric. That means it uses both letters and numbers, making it perfect for things like shipping labels. And then there's code 128, which is a super high-density code. It's a favorite for logistics because you can pack a lot of information into a really small space.
So this all might seem kinda technical, but what if you're a business owner with a new product? How do you actually get a barcode onto your stuff? How does an idea become a scannable label on a store shelf?
Well, it's basically a 4-step journey. First, a business has to get what's called a company prefix. That's their unique ID number for the whole world. Then, they start assigning specific numbers to each of their products. After that, they use software to generate the actual scannable image of the barcode. And finally, they print them out and stick them on. And this is a really crucial point. You can't just make up a number if you want to sell your product in major retail stores. No way. To get a universal code that works everywhere, businesses have to register with a single global standards body called GS1. You can think of them as the gatekeepers who make sure no 2 products in the world accidentally end up with the same code.
And yeah, that process does come with a cost. Just to give you a ballpark, a business might pay around $2,500 to GS1 just to get that company prefix. But what that fee does is give them the ability to create unique barcodes for over 1,000 different products.
Okay, this brings up a really common point of confusion. Let's say a company makes a batch of 100 dog collars. Do they need 100 different barcodes for them?
The answer is a big, fat no. A barcode identifies a product type, not an individual item. So all 100 of those identical dog collars, they would all share the exact same barcode. You'd only need a new barcode if you introduced a variation, like, say, a new color or a different size. This brings us to another term you've probably heard thrown around, SKU. It's often confused with the barcode, and while they're both used to manage its inventory, they actually play totally different roles.
Really, the difference is all about scope. A SKU, that stands for Stock Keeping Unit, is purely for internal use. A retailer creates their own SKU system to track their own inventory. The barcode, on the other hand, is universal. It's a standardized number that's the same for that product, no matter which store in the world is selling it.
So here's a perfect example. A retailer might create a SKU like this. See how it's easy for a person to read? MED GLD Hoop 01. It tells their warehouse staff the size, material, and style. But that code is completely meaningless to any other company. It's their own internal language.
So, if you want the easiest way to remember this, it's this. SKUs are for talking to yourself, for organizing your own stockroom. Barcodes are for talking to the rest of the world, making sure your product can be identified, tracked, and sold by any retailer anywhere on the planet.
I mean, when you think about it, from that first beep at the checkout to managing these gigantic warehouses and tracking packages as they fly across the globe, these simple lines aren't just a convenience. They're the backbone of modern logistics. The scale of commerce we have today would be literally impossible without them.
So next time you see one, you'll know it's not just a random pattern. It's this brilliantly simple and efficient language that lets the entire complex system of global commerce just work smoothly every single day.
What the barcode did that was so revolutionary was give every mass-produced object its own unique digital fingerprint. And it really makes you wonder, what's next? What other everyday objects in our lives are just waiting to be given their own unique universal code?